In the summer of 2026, one of humanity's most critical links to the cosmos was nearly swallowed by flames. The Sierra Oeste wildfire, a massive, fast-moving blaze outside of Madrid, Spain, breached the perimeter of the Madrid Deep Space Communication Complex. Emergency crews evacuated 90 personnel from the site. In the chaos, flames severely damaged cables and water lines, ultimately flooding the base of the massive antenna with 200,000 gallons of glycol-contaminated water. To avoid radio interference, this complex was built in a remote, isolated valley surrounded by dense vegetation. That isolation makes it perfect for listening to deep space, but incredibly vulnerable to a regional terrain fire. When the smoke settled, the physical damage to the infrastructure meant our most advanced tools of cosmic discovery were instantly deafened and blinded. The Madrid facility is a crucial node in NASA's Deep Space Network, or DSN. This network acts as the sole lifeline for sending commands and receiving data from spacecraft millions of miles away from Earth. Without it, we lose contact with our highest-profile missions. The Artemis lunar program, the Mars rovers, and the James Webb Space Telescope all rely entirely on the DSN to function. The sheer scale of these antennas is required to catch the faintest whispers from the cosmos, like the incredibly weak interstellar signals sent back by Voyager 1, the farthest human-made object from Earth. If the terrestrial infrastructure of the Deep Space Network fails, our entire multi-billion-dollar interplanetary fleet instantly becomes untethered space junk. Communicating with deep space probes presents a tricky geometric challenge. Because the Earth is constantly rotating, a single ground station can only maintain a direct line of sight with a distant spacecraft for a fraction of the day. This diagram shows NASA's elegant architectural solution to the rotation problem. They positioned 3 identical communication complexes roughly 120 degrees apart around the globe, one in Madrid, one in Goldstone, California, and a third in Canberra, Australia. As the Earth turns and a spacecraft sets on the horizon in Madrid, the connection is seamlessly handed off to the Goldstone station, maintaining an unbroken link. But NASA also planned for disasters. They developed the Emergency Control Center, or ECC protocol, a failsafe designed to activate if one of these 3 nodes suddenly goes dark. Looking at this logical overview of the ECC network, you can see how the system reacts. During an emergency activation, the ECC prioritizes bandwidth. It reroutes essential telemetry, tracking, and command data to the surviving stations, while immediately dumping non-essential services like radio astronomy. NASA engineered the DSN as a triple redundant marvel, fully capable of surviving the Madrid fire, in theory. The critical caveat of the ECC backup plan is that it relies entirely on the remaining 2 stations operating at 100% capacity. When the Madrid complex caught fire, the network was already compromised. The Goldstone complex in California was limping. In September of 2025, Goldstone's massive 70-meter antenna, known as Deep Space Station 14, suffered a mechanical over-rotation while tracking the Juno spacecraft. It was classified as a Type A mishap, resulting in over $4 million in damages and knocking the critical antenna completely offline. With Madrid burning and California broken, a network built on absolute redundancy was instantly reduced to 0 failsafes. Due to the severe fire and water damage, the Madrid complex is projected to remain offline until 2028. This created a terrifying operational bottleneck. Humanity's entire deep space portfolio is now being filtered through a single functional 70-meter antenna located in Canberra, Australia. For active missions, this bottleneck means delayed orbital maneuvers, heavily restricted science data downloads, and high-risk blind spots where spacecraft have to navigate without Earth's supervision. We pour billions of dollars into engineering spacecraft that can survive the hostile vacuum of space, yet we largely ignore the growing hostility of our own planet. As climate change accelerates extreme weather events, like the Sierra Oeste fire that crippled Madrid, these terrestrial ground stations face existential threats. The weakest link in our journey to the stars isn't the spacecraft we launch, but the fragile earthly infrastructure keeping us connected to them. To uncover more of the hidden, vulnerable systems that power our modern world, make sure to subscribe to The Explainer.